everyone, welcome to the next session of Finite Element Analysis. I am solving another problem on truss element. This is question 16 of Direct Application of E.M.E. Analyze the plane truss for nodal displacements, reactions, elemental stresses and strains. Verify for force equilibrium conditions. So this is the truss which is given to me. The value of L1, L2 is given in meters. I'll convert them into mm. P1 is given here. P2 is also given. E, Young's modulus, is given for the elements, and area for all elements is given as 6 centimeters square. Again, I'll convert as per my requirement. First thing that I'm going to do is discretization diagram. So I'll just take up this diagram itself. Okay, let's mark the elements first. So let me call this as element 1, element 2, and this as element 3. Element 1 is between node 1 and 2, 2 is between 2 and 3 is between 1 and 3. Here let me say it is 0, 0. So this will be 600, 0, and this I have to calculate. Okay, let's mark this as x1, y1, this as x2, y2, and this as x3, y3. Also, I need to mark the degree of freedom. So this will be 1, 2, this will be 3, 4, and this will be 5, 6. Now the only thing left over here is this coordinate. Now for that, if you assume this triangle over here, if you look carefully, this is 60 degree. Suppose if I take tan of 60, tan is always opposite upon adjacent. This height is given to me L2 as 400, and this distance, let me mark this distance as x. So this will be upon x. When I calculate, I get the value of x as 230.94 mm. I will be taking this as 231 mm. So this is the value of x over here. So this coordinate now becomes 231, 400. So this is how I'm going to discretize this entire diagram. Now I'll go to step 2, which is development of EME. Now don't get confused, this is obviously the discretization diagram. Since it is given in the question, when you are solving it in the exam, obviously you will be reproducing this diagram in the paper. So I have directly shown you, and obviously you are also going to do the same on the answer sheet. Now this is my step 2, development of EME. First, I need to draw the table, which is element number. Then I have nodes, which will be I and j. Then I'll have xi, yi, xj, yj. Then I have the length of each element L. And then I'll calculate L, M, L square, M square, Ln. Now I'll start with element 1. I can observe element 1 is between two nodes 1 and 2. So here I'll write element 1 between node 1, 2. This will be x1, y1. x1, y1 is 0. J is 2. So this will be x2, y2, which is 600 and 0. The length of this element L1 is 600. L will be xj minus xi upon L. So it will be 600 upon 601. M will be 0 minus 0 upon 600, 0. So this will be 1, 0, 0. This completes for element 1. Next I'll go for element 2. When I'm solving for element 2, I can see it is between node 2 and 3. So here I'll write down 2, 3. This will be x2, y2, which is 600, 0. And j is 3, so x3, y3, the value is 231, 400. So here I'll write down 231, 400. Okay, the length is supposed to be calculated. Now there is a formula for calculation of this length as well. This formula you have already studied in mathematics, which is xj minus xi the whole square plus yj minus yi the whole square is equal to length square. So when you substitute in this formula, you will get the value of L for element 2 and 3. So if I substitute, I get this value as 544.2. This L value is xj minus xi upon L. I get it as minus 0.678 and M I obtain as 0.735. L square I have obtained as 0.46 and M square as 0.54. L into M I obtain as minus 0.5. So this completes for element 2. Next I'll go for element 3. Element 3, if you observe, is between node 1 and 3. If you want, you can write 3 and 1, no problem. But see to it that you maintain this consistency till the end. When you are writing the EME, you also write the degree of freedom number. So when you write 1, 3, I'll write 1, 2, 5, 6. If you are taking 3 and 1, then write 5, 6, 1, 2. So accordingly, just go till the end. So here I am writing 1, 3, x1, y1 is 0, 0, x3, y3 is again 231 and 400. The length can be calculated by the formula I gave you. So the value I obtain is 462. L I obtain as minus 0.5. M I obtain as 0.866. L square is 0.25. M square is 0.75 and Lm is 0.43. So this is all the values that I obtained. Next I'll write the EME. AE upon L. Again I'll have L square, Lm, M square. I'll write here L square, Lm, M square. Whatever I write here, just write the negative in these positions. Copy over here, minus L square, minus Lm, minus Lm, minus L square. Here I'll have U1, V1, U2, V2 raised to E is equal to P1x, P1y, P2x, P2y raised to E. Obviously here also I'll write down E so that you write down the values for the corresponding element. I'll start for element 1. The value of E is 180 gigapascal. The value of area is 6 centimeter square. So area will now become 600 mm square because it was 6 centimeter square. E will be 1.8 into 10 raised to 5 Newton per mm square. The length of the first element is 600. The value of L is 1. These are 0. So minus 0, 0, 0. Minus 1, 0, 0, 0, 1, 0, 0, 0. I think you can fill up now. So here I'll copy the same one. When I solve this and take a 10 raised to 3 outside, the multiplying number is 180. Element 1 has degree of freedom 1, 2, 3, 4. 1, 2, 3, 4. Next I'll go for element 2. A is 600. E is 1.8 into 10 raised to 5. The length is 544.2. Here L square is 0.46, 0.5 Lm, 0.5, 0.54. So I have copied them with their signs. I will copy the same thing here. I'll copy them with an opposite sign. Copy the same thing here. Now you know how to solve this. So I'll multiply, take a 10 raised to 3 outside. The number that I get, I'll be multiplying with each value here. So when I multiply, I get this as 10 raised to 3. Copy the same thing here. Here I have u1, v1, u2, v2 raised to 2 is equal to p1x, p1y, p2x, p2y raised to 2. Element 2 has degree of freedom 3, 4, 5, 6, 3, 4, 5, 6. Last I will solve for element 3. For element 3 I will directly write the values. I think you can solve now. So 10 raised to 3 common. All of them are positive. So I will take negative sign for all of them here. I will copy the same thing, sorry, not negative sign will come here, minus 58.44. Copy the same thing here. Here I have u1, v1, u2, v2 raised to 2, so raised to 3. Element 3 is between node 1 and 3. So the degree of freedom for the first one is 1, 2, third one is 5, 6. So 1, 2, 5, 6. Next I will go for step 3, development of GME. I will have a 10 raised to 3 common and I have 6 nodes. So I will write down 1, 2, 3, 4, 5, 6. And here I have 1, 2, 3, 4, 5, 6. Make this enough spacious so that you can write the addition values also properly. u1, v1, u2, v2, u3, v3. Now I'll start with placing of the elements. Element 1 is between 1, 2, 3, 4 and the value is 180. So I'll place it here 1, 2, 3, 4, 1, 2, 3, 4. So I have 180, 0, 0, 0, minus 180, 0, 0, 0. Next I'll go for element 2. Element 2 is between 3, 4, 5, 6. So it will be 3, 4, 5, 6 and 3, 4, 5, 6 over here. And these are the values. So let me place them. Plus 91.3 minus 99.25, 91.3, 91.25. Last I'll place element 3 which is between 1, 2, 5, 6. So it is 1, 2, 5, 6, 1, 2, 5, 6. So I'll start with this value 1, 2. It is plus 58.44, 101.21, 101.21 and 175.32. So this is just placed here 1, 2, 1, 2. Next I have 4 elements here. So minus 58.44. Next I have here 1, 2, 5, 6. So minus 58.44 and last 4 over here. So plus 58.44, 101.21, 101.21 and 175.32. So this is how you're going to make the GME. Next I'll go for step 4, imposing of boundary conditions. These are the variables that I have. I'll go to the question. When I observe the question, first node is hinged. So u1, v1 will be 0, no displacement at these points. Node 2 has a roller. Now the property of roller is that it can move along the x-axis but it cannot move in the y direction. So it is constrained to move in y direction. So the value of V2 will be 0. When I look at the third node, there is two directional forces. So obviously there will be displacement in U3 and V3 direction. P2 and P1 is given. Both are negative if you observe. P1 is downward, P2 is towards the left. So I'll take both the values as negative. So let's substitute the values now. I'll have U1, V1, 0. Right here node 1 is hinged. Next I'll go to U2, V2. V2 will be 0 because it is a roller and it can move in the x direction. So here I'll just write down node 2 is roller. Now since U1, V1 is 0, this will be reaction forces question mark. U2 is free, so obviously this will be 0. Since this is 0, this has to be a question mark. At node 3, there are two load, P3 x and P2 is the load, so this value is 2 kilonewton towards the left and P1 is downward, so 5 kilonewton. So here I'll write down minus 2 into 10 raised to 3 Newton and minus 5 into 10 raised to 3 Newton. Now here if you observe first value U1 is 0. So I'll ignore first row, first column. V1 is also 0. So ignore second row, second column for some time. Also V2 is 0. So ignore fourth row and the fourth column for some time. So whatever remains over here, write them down as a matrix. Calculate U2, U3, V3 and then calculate P1 x, P1 y and P2 y. So I have a 10 raised to 3 common. I get 271.3 minus 91.3, 99.25 minus 91.3, 149.7, 1.96. Here I have 99.25, 1.96, 282.5. Here I have U2, U3, V3 is equal to 0 minus 2 minus 5 into 10 raised to 3. This directly gets cancelled. So on writing these equations, I will get, when I solve these three, I get U2 as 3.02 into 10 raised to minus 3 mm. U3 I obtain as minus 0.0113 mm. And I get V3 as minus 0.0187 mm. Now next I'll write the equations for calculating P1x. So I have a 10 raised to 3 common, minus 180 U minus 58.44 U3 minus 101.21 V3 is equal to P1x into 10 raised to 3. So I get P1x as 2 kilonewton. Next I have minus 101.21 U3 minus 175.32 V3 is equal to P1y into 10 raised to 3. I cancel these two and I get P1y as 4.41 kilonewton. And lastly 10 raised to 3 minus 99.25 I get P2y as 0.583 kilonewton. Next let's check the values. Summation of force in x direction should be 0. So I have P1x, P2x plus P3x. So this I directly get as 0, and summation of force in y direction is also 0. So P1y plus P2y plus P3y should be equal to 4.41 plus 0.583 and minus 5. So this is also approximately equal to z. Hence I have checked my values. If you go for calculation of stresses, you'll get sigma 1 as 0.9159 Newton per mm square. This will be tensile because it is positive. Sigma 2 you will get as minus 1.3374 Newton per mm square. Now since it is negative, this will be of compressive type. I think you can calculate these values, they are very simple. And sigma 3 I obtain as minus 8.5 Newton per mm square, which is 8.5 Newton per mm square compressive. So with this I end the session. I hope you have understood the numerical. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to my channel. Hit the bell icon for latest updates of my videos. See you in the next session. Thank you.